One of the standard array algorithms we should know is finding the minimum or maximum value. We should have a couple of them memorized because then we can change it for however we need it. Okay, so we're going to find the minimum of an array. So the first thing I'm just going to do is write out an array so we know what it looks like. So here's my array. It's called ARR. You see they passed it in and they told you it was an integer array. So I'm just going to make this array up in my head, but I want to go through and find the minimum. So I'm going to look here and I'm going to say, are you the minimum? But currently I have nothing to compare it to. So I need to create a memory location for the minimum. So I'm going to say int min is equal to. Now a lot of people like to set the min to 0 because we set totals to zeros and counts to zeros, but we could have negative numbers. So setting the minimum equal to 0 is not what you would want to do because there could be smaller numbers. You can set it to the smallest integer number, which is what the integer.min value. But what I always do is just set it equal to the first thing in the array. So right now, currently, I have the minimum is going to be 2. So now I have to go through each element of the array and compare it. So I'm going to compare multiple things, so we're going to do a loop. So it's a standard for loop. So for int I, normally we start at 0, and it wouldn't hurt if I started at 0, but we already have the minimum set at 0, so I'm going to start at 1. I less than min.length. I plus plus. So when we go through, we're going to take our array element that we found. So we're going to say if the new position in the array is less than our current minimum, then we know it's going to be our new minimum. Now remember, if it's only one line with the if statement, you don't need brackets, but I'm just going to go ahead and put them there. So let's see what my code looks like so far. We go through and we have our min is equal to 2. So I'm going to traverse, I'm going to say I equals 1. So here's I equals 1. And it's going to say is -1 less than my minimum 2. And that's true. So now I'm going to change my new minimum. Then we go to the next one. We're going to be here at position 2. And it's going to ask, is position 2 less than our current minimum? And it's no. So it's not going to do anything in the if statement, and it's going to do the same thing again. So we found the minimum, but the last thing we need to remember to do is there's a return type. The return type is an integer, so they want us to return the minimum. This problem would change slightly if they wanted the position of the minimum. If you wanted the position of the minimum, you would also have to store the I anywhere. So you'd have the min, which would be the element, and then you'd also have the position to store. The next one we should know is being able to find the average of a passed array. So we have public, static, and it should be double, sorry. So our return type is going to be a double, and then average, and then we're passing in our integer array. Well, if I'm going to find the average, the first thing we have to do is add up each thing in my array. So we have to create a total. So int total. And here it's okay to set equal to 0 because we're going to be accumulating something, not comparing something. So then we're going to traverse the array and add each element. I'm going to go ahead and do it enhanced for loop this time, or for each. So for int, we give it a temporary name A in the array, and then you're just going to add that to the total. Okay, so what's happening here is first thing, let me fix that total. So what's happening here, total is equal to 0. It's going to take the first position, which is 1, add it to the total. Then it goes to the next position, and it's going to add it to the total, and then the next position, and add it to the total. Now remember, with enhanced for loops, we can only access the elements in the array. We cannot modify them, and it must go from the very beginning to the very end. Okay, so now we have our total, but if we want the average, now we have to divide by the length of the array. So return, so I don't have to make another memory location, the total divided by array.length. Now let's stop and think about that. When we divide an integer by an integer, you're going to have integer division. So right now this is not going to work, because if my total is, let's say my total here was 5 and I have 3 elements, it's going to return 1. Okay, so I've got to change some things. There are a couple ways we can do this. We can either change this to a double, because once you have one double, it'll up there. And the other way that AP often does it, they cast it. So double total, then divide by array.length. Enhanced for loops or for each loops do help concise the code, make it a little bit concise and easier to read once you get used to them. The next one is a method called find even. It returns true if there's at least one even element in the array. So I'm just going to go through my array, whatever it is, and I'm going to pick up the first element and I'm going to ask, are you even? If it is, I'm done. I just return true. It's not even, so I'd go to the next one. I'd ask it if it's even. Then I go to the next one. Are you even? Oh yes, he is even, so we know that we found an even, we return true, we're done. If we make it all the way through the array and don't find one, that's when you return false. So I don't need to create any memory locations, there's nothing I need to store, I just have to traverse this array. So I'm going to use an enhanced for loop. So for, and this is an integer array, so the data type is integer, give it a temporary name, A, in the array. Now let's remind ourselves, how do we know if something's even? Well, if we do mod 2 and it's equal to 0, that means it's even, because remember mod is checking for the remainder. So we're going to say if A mod 2 equals 0, then you're going to return true. But if we make it all the way through this entire for loop and you don't find one, return false. Things that are important, this return must be out of the for loop. This one right here needs to be inside where you checked if it was even. Remember also, when you're checking for equality, you use equals equals. When it's assignments, you do 1 equals. Okay, so this one's starting to work with strings, and it wants us to return true if all the elements of the strings are between 5 and 10 characters. I guess we're going to say not including 5 or 10. It wasn't really clear, but between would mean in between those and not including those. Okay, so I want to know if they're all that length. So if I find one that is not, we're done. So we only need to find one string that's not between 5 and 10 in length. So I'm going to just create some words. So we have my dog is Ginger, and my cat is Rex, and we have a lizard called Ollie, and I'm just going to add an extra S here just so that we have different ones. And I also have a cat, OJ. So my animals do have very small names. So looking at Ginger, hers has got 6 letters in her name. So she does not meet the, she is in the thing that they wanted. They want us between, why is this not writing? They want us between 5 and 10. So Ginger meets the criteria. Rex here, Rex is always a problem. He's only 3 letters, he does not fit, so immediately we know that they're not all between 5 and 10. So remind ourselves how we find out if a string, what the string's length is. And remember, you would do dot length and open and close because you need a method to figure out what the length is, because every string could have a different length. So I don't need any new data types. So we're just going to traverse our array. So for, I'll do a full loop this time, int I equal to 0, I less than arr.length. That is an array, it's a fixed length, so we don't need a method, I++. And we're going to say if ARR at position I dot length, and we're looking for the false one, because if we have one false, we're done. So if ARR dot length is less than 5, or ARR dot length, ARRI dot length, sorry, ARR position I dot length is greater than 10, we return false. Only if we make it through the entire array and not return false, we would return true. Now remember, our method headers tell us so much information. We know that it's static, so we're not using objects. We know that our return type is Boolean. We know what's being passed in. There's lots of information just in the method headers. Another thing we should always be able to do is to swap two elements. So if I have 5, 2, 3, 4, 5, and they gave me an array, and they gave me the first one I want to swap, and then the second one I want to swap. So here's my array. Let's say the first is equal to 2, position 2, and then the second is equal to position 3. That would say I would want 0, 1, 2. I would want these two positions to switch. Now remember, you can't just switch them. You have to create a memory location for that new one, because once I move 4 over here, 5 is gone. I can't get it back. So the first thing we got to do is store the temporary. So int temp, I know it's an int because it told me here it's an integer array. So int temp is going to be the array at, and I'll say first. So right here I know temp is going to be my first number, which is 4. Now I'm going to take my second number and put it into the first number. So ARR first is going to be ARR second. And then lastly, I'm going to put the temp into the second. Notice this is a void. A void means there's no return type. So that's all we have. You could not have done an enhanced for loop or anything like that, not that we need a loop because we were changing the array. Just remember, whenever it's an enhanced for loop, you can only access it in the exact order and make no changes. This wants us to shift everything to the right. So here's my array, just making it up. Again, it's integers. And it wants to shift everything to the right. So now this will be 1 over here, 4 over here. Oh, sorry, 3. I didn't shift it, did I? And then 4, then 5, and it wants the last element to move to the front. So again, I'm going to have a temporary variable. So I'm going to let my temporary be this last one. So int temp, and I'm going to get the last element of the array. The last element would be ARR.length minus 1. So now, currently in temp, I have the position, which is currently, I guess, position 4 in mine, is stored as 7. So now I'm going to write a loop and move everything over. So 4, int I, and I think this one's going to be a little bit easier if I start backwards, and we hardly ever traverse backwards, so let's just do something different. So ARR.length minus 1. I's got to be greater than or equal to 0. I minus minus. Remember, I always mess that up. Double check that it's I minus minus. Okay, so what I'm going to do is whatever's in position I minus 1 is now going to position I. But I got to go back and put what is missing in position 0 now. So ARR 0 is now going to be that temp. Double check that there's no return type. It's a void, so we access the array, we change the array, and that's all we needed to do. Now, over here is algorithm steps we can do to reverse an array, but I think it's much easier if we just create a whole new array, copy it over backwards, and then change the memory. the name of it. So first thing I'm going to do, here's my imaginary array. It's 1, 2, 3, 4. And when I'm done, I want 4, 3, 2, 1. So I'm going to make a new array. I'm going to call it ARR2. Hold on, that didn't make it correctly. I've got to do the data location. So it's got to be an integer array. ARR2. It's going to be a new integer array. And the length is going to be the length of the original array. So now what happens, I really have ARR2. It's got the same length as ARR. And right now, the only thing in there are zeros because that's the default data. Remember, if it's an integer array, it defaults to 0. If it's a double, it defaults to 0.0. Strings default to null, and Booleans default to false. So now I'm going to traverse the length of the array and just copy everything backwards. So 4 int I equals 0, I less than array.length. Nope, don't need parentheses, that's not a method. I++, and we're going to say ARR2, and it's got to go backwards, so it's going to be ARR.length minus 1 minus I. That's going to be equal to ARR at position I. Okay, so let's check that. So let's see, ARR.length is 4. Minus 1 is 3, minus I is just 0, so it's still going to be 3. So I is going to be 3. That's my position. Here's 0, here's 1, here's 2, here's 3. So we are starting at the third position. So it's saying ARR, that is going to be ARRI. I is currently 0, so this is now going to get you a 1. The next time you traverse it, I is going to be 1. So now it's 1, and I'm going to have ARR.length minus 1 minus I, so that's now going to be position 2 is going to equal to position 1, and so on and so forth. But our new array was called ARR, so we have to make sure we change it. So ARR is equal to ARR2. So now we copied it back over and just kind of changed where the pointer was, or the reference. Those are some of the things you should know for regular arrays, and we'll do some with array lists in a second, or in another video.